Hello, welcome. My name is Simon Polina. We have two sections given in the assignment. So, first I'll go with the section A. So, here we, so in section A, I'll show how clean broad tweets and load them into MongoDB. It's Python code. Here. So we connected to MongoDB and then we loaded all the files, whatever in it. And then, so here is a cleaning text and date parsing and UTC functions before and after tweet snippet. So I start with the lightweight Python pipeline. It strips like URLs and mentions and also normalize white spaces and passes created at UTC, and I also extract hashtags, mentions, and then link domains, so each tweet becomes a tidy document with a bold raw text and a clean text variant. And also we derived user metadata fields and a single clean tweet document highlighted like user ID and screen name and user location and user URL domain and has links and then hour of the day. So attach user fields and derive convenient features like has link, user URL domain, and temporal attributes. This keeps later pipeline simple and fast. And writing to Mongo and idempotent. So a short Python upset loop with update 1 or bulk writes a console line x tweets upsetted. I also loaded into tweets clean using upsets, and reruns don't duplicate data, and each record keeps both each record keeps both the original timestamp string and canonical UTC created as well. And there is index strategy. Index strategy, like I created 4 targeted indexes like time, hashtag plus time, and then domain plus time, and then user plus time. These match the exact shapes of our queries, growth by week, link bursts in a minute, windows, and per duplications. So the server can do index range scans instead of full collections of scans. And coming to section B, we have done everything section B in the Neo4j. So here we imported queries and visuals, and so title card. So graph data model and queries in Neo4j. In section B, I import the payment CSV, extend the model for temporal analytics and indexes, and answer 4 analytical problems. So data model and why. And the core pattern here is like client may purchase, client send transfer, and client receive. Like I represent purchases and transfers as a first class transaction nodes with the canonical UTC. This makes money flow explicit and supports queries like fan out, cash out, and seller hotspots. Here's the first one, like we asked in the part A, creating indexes and constraints and indexing. So uniqueness constraints gives in-event loads. Time indexes turn all windowed analytics into index range and scans. So lookup indexes on client fields accelerate entity resolution and same derivations. And here importing like temporal futures. I love base node files and then purchases and transfers. Here purchases and transfers. Converting time offset into the absolute time. From there, temporal futures are trivial, and because transactions are nodes, I can attach the risk futures later without schema changes. And these are the relationship derived. And moving on to the part 2 of section 2. So we got top spenders between the dates, so ASD on a given day, and show parameters and a winners table with the quantities, and most negative balances or outgoing purchases plus sent, and total incomes, and pass on clients to a store. And another question they ask is cash out behavior for each client. How much is transferred within 1 to 4 hours after their purchase is written in cash out? And in here, like I parameterize time windows and sellers, compute sums safely with optional match groups, include like correctly, yeah, here includes correctly a net outflow seller specific pass through hours of heart. And so purchases subgraph around the here the problem 3, like part 3. So here are a purchase subgraph around the BZS store, and then transfers Hego network for a cash out, and optionally a same identifier cluster and voiceover and for the video. And I show on a tidy purchases cluster and one transfers ego graph. If you have added the same edges as quick cluster, show illustrate identity overlap across the accounts. And section A gave us a clean index documents, and section B maps the behavior into the graph with constraints and time aware queries. Together they deliver fast and like explainable analytics and clear visuals. Thank you.